solving snakes and ladders, and this question, let's just read through it. Basically, we go in a reverse order where it's not 1, 2, 3, 4, 5, 6, 7. It's following a certain style of going from the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, like a snake. And when there are letters, we have no choice but to take that letter. So in the last index, in the last row, we have 15. So when we reach that grid, we have to move our value. We have to update our value to 15. And same for snake. Let's say, okay, so 35, same here. It goes up to 35. And where there's like 17, when we reach here, we have to go to the tail of the snake. So it's kind of like whenever there's a value that's not -1, we just go to that value. We just update our current position to the value in that grid. Okay, so we have 6 choices. So we roll a dice from and get a value from 1 to 6. So for example, we start from here. The positions that we can go is cur +1. Oh, where is it? Cur +1 up to cur +6. So it will be from 2 to 7 inclusive. Okay. And we'll be using a BFS because whenever you see like the least number of moves or the shortest path, this is the shortest path from here to here. Okay, so that's when we use BFS and not DFS. DFS is depth, choosing one path and going really deep, but BFS is kind of spreading out through levels. So let's go. Okay, so I'm just going to initialize n as length. Okay. For DFS, we need a queue, right? And same for DFS, we need a Boolean visited to mark our journey, and it will be n plus n times n plus 1. Okay, we're not gonna zero index this one. Okay, and yeah, and let's go. So we loop through. So we need the least number of moves. So for int, by the way, we need to add q.add our first one here, this value here. Okay, and our condition to end our move is that as long as our queue is not empty, we just keep incrementing our move. Now, and for int, let's say, so when we have a queue, we want to iterate through every value in our queue, right? So we do size less than q.size, size plus. By the way, we don't do like for int size. Oh, I did the wrong way, sorry. We don't do like this. We actually do from int size equals q.size, size greater than 0, size minus. Because what I did just now will depend on the size of our queue, but we want to iterate through this for loop when so when we have like 3 values in a queue, we want this to run 3 times, right? This will run, but what I've done just now, that would also run 3 times in normal circumstances, but I'm going to do something here in our for loop. So So if we have visited, oh, by the way, we need to pull our value. So int num equals q dot pull. So if we have visited this grid before, then we continue to our next value in our queue. If not, and this value in this position has not been visited, then we mark it as visited by marking it as true. Okay. And from that number, we have 6 choices, right? So from I equals 1 until I is less than or equal to 6. So 1 to 6. But very importantly, we don't want to add, for example, we're at 35, we don't want to add over 36. So we have to check and num plus I is always less than or equal to our n times n, because we don't want to go over I plus plus. So, and next would be our current value plus I, right? So for example, it would be 1 plus 1, so it will be 2. Okay. And if next has a value that's greater than 0, like 15 or blah blah. Oh, actually, right, so we have this number here. We have to translate this value to this special board. And for that, let's call that a board value equals, and we're going to create a function called board value that translates with parameters board and next. We can't directly use this next value because it's not it's a different style. Like if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we can use that, but this one, our value starts from the bottom and in a really weird way. So we have to create, let's create a separate function that takes care of that. Int number. Okay, so our int of old row, so old row would be int n is board.length. So old row is actually just our number. Let's say we have like value 2. Okay. Yep, value 2. And the old row would just be n minus. Oh wait, I'm kind of getting numb here. Yep, I think it's n minus num divided by n. And for like int old column, it would be just something modulus n, right? For row it's just dividing, and for column is getting the modulus. But let me just check the thing. Oh, it's actually just num minus 1. So for example, let's see 11. Okay, 11 minus 1, 10, and 10 divided by 6 is just 1. Okay, that makes sense. Our old row would be, this is row 0, this is row 1. But we want to convert it so that we get here, we get this row, I mean from the top bottom. So we translate that, let's call it row, and that would be just n minus 1 minus old row, right? It's 5 minus 1, so we get here. Imagine that's like a mirror here, and we just get this value. It's like a translation, like a reflection. Okay. And same, old column would be num minus 1, but actually we have to be very careful, because while our row 0 follows this ascending order, row 1, row 3, row 6 follows a descending order. So we have to check if our old row modulus 2 equals 0, then we just use this. Oh wait, this comprehension. If not, we have to do n minus 1 minus old column here. That makes sense, right? And we just return board of row and column. Okay. Actually, I've wrongly explained old row. I said, yeah, so actually the wrong row is from row 0, row 1, row 2, right? But we want to translate it. So imagine there's like a mirror here. We want to get this value, right? Because our values don't start from top, our values start from 0. Sorry about the confusion. So we want to get this actual row, not this row. So that's why we do this. Okay. And so if our value is greater than 0, like 15, 35, then we update our next value to our board value. That makes sense, right? And if we have not visited this possible path, then we add that to our q.add to our queue. And if all this fails, we just return -1 because there's no possible way. Not Boolean, it's visited. And why is it all Boolean? Visited. Oh, this would cause I think a Stack Overflow error because it will keep running. If our num equals the value that we're looking for, 36, then we return move. Illegal character. Why is that dash? Okay. Okay, submit. Okay, great. Yeah, sorry about the confusion. Our row always start from here, from top. But this grid starts from bottom. So that's why we mark our old row like here. And we just do a n-1 minus these rows. So if we have row 1, it's going to be 6 minus 1 minus 1. So it's going to be here. Row 0, 0, 1, 2, 3, 4 here. So we kind of translate the rows and columns. Okay, so that's it, and I'll see you guys next time. Bye.